What's up, everybody? Welcome back. Today we are working on replacing Google Maps. I would demo my issues with Google Maps, but if I open Google Maps right now, you will see exactly where I live, and I'd prefer not to do that. So instead, I will describe my problem and draw it for you. So when I use Google Maps to figure out where I want to go, I'm often taking transit. And anytime I take transit, Google Maps seems to think that I don't have legs, and it seems to think that buses are on time. Both of these things are wildly false, right? I do have legs, and the buses are always fucking late or early, like who knows, right? And so I find that, I live in Vancouver, which looks like something like this. This is like downtown, this is UBC, and then Richmond's kind of like over here, whatever, right? So you have like the B line, for example, right? The 99, it goes down Broadway across the whole city, and it's fucking fast, right? It comes like every once in a while, or you have like the train here and like here, right? And if I'm like here, I'm right over here. It's instead of, if I'm trying to get to downtown, instead of it telling me to walk up here, take the 99, and then take the train, it will tell me to wait for this bus that drives like this. And this bus is wildly inconsistent. Like, if I miss that bus, I'm gonna have to wait half an hour for the next one, right? But if I were to just walk like 3 blocks, then all of a sudden, now I can leave at any time, and the variance between the time I get there is gonna be like 3-5 minutes, and like, it's just gonna be like way faster. And so I don't like, all I'm kind of saying is I don't like the way that Google Maps tells me to get places. And I find that I've like looked at a couple other options in the past, and they all kind of make trade-offs that I don't like. And so what that brings me to the conclusion that every option is going to have trade-offs. And so what I want to do is I want to make a path planning algorithm that has that concept baked in. I want to make sure that we make a path planning algorithm that's like super customizable to the point where any trade-offs that I feel like at this particular time I can easily make, right? So maybe I don't want to walk through Gastown in the middle of the night, so I can like draw a little block up here and say like don't fucking put me through here right now. And maybe I don't want to walk down a busy street, and so maybe I want to like wait like bike routes or something that have like, like better pathing through the city, but without like the like noise and danger of being by a lot of cars. Maybe I want to go on bike routes because I'm riding my bike. Maybe I like don't feel like taking the bus today. Maybe I do feel like taking the bus today, right? And maybe there's all these like tunables that we could like kind of bake into the algorithm and make it so that we can basically get the output that we want. And so the overall plan is to kind of like scrape some data from the internet about like my city. So OpenStreetMaps, TransLink is going to be an important one. Maybe like elevation data. Maybe I don't want to like walk uphill, stuff like that. And then I want to make an algorithm, right? And so the plan for today is to just try to like get a map. I think that like visually it's going to be very important. That's probably where we want to start, is just looking at some data, rendering it, and making sure we understand it. So that's the plan. And so yeah, we're gonna try to like get some OpenStreetMaps data, render anything in a browser with Webgl, because I think that there's going to be a lot of data here. And since I want this whole thing to be run like completely client side, because I think that's more fun, we're gonna have to make sure that we can render everything. And so Webgl is probably the thing here, because there's probably gonna be a lot of data to render. Then we want to like render something from WebAssembly, and then once we have that, we can like render the data from the map after we pre-process it and stuff. So that's the plan. Let's just jump into it. Let's just jump in. Okay, new project. What I have here is a OpenStreetMaps set of data that I downloaded from, I think it was a BB Bike, something like this. Yeah, BB Bike extracts. So I just went in here, and I don't remember what I downloaded. I think I drew out a section, like I think I just kind of like drew a box around like this area-ish, like probably like around here. And then they needed like me to register an account and stuff. So I kind of did this pre-stream, but I downloaded some data. I have it here. It looks like it's an XML file that has these like concepts of nodes, as well as actually we can probably look up the data. That's probably important. Shit, I just locked my computer screen like a dumbass. Did that like fuck my stream up? No, we're good. That's pretty funny. I hope you guys didn't just see my password. That would suck. So let's see. OSM OSM data format. I was on their wiki. Hunter 2. Shit, he saw it. I was on the website yesterday, and I had somewhere where they kind of documented a little bit what's in here. Here we go. Okay, so then an example OSM file has nodes, ways, and relations. And I think they documented what all these are. But when I was reading through this yesterday, it seemed kind of like relationships are not something that I care about right now, and nodes and ways are. Here we go. So nodes are just a single point in space defined by latitude and longitude. A way is a link of nodes, essentially. So I think what I want to do here is I want to look at the nodes that they have, and they're going to have IDs or something. We're going to like try to walk these nodes, figure out where they all are. And then when we look at ways, we're going to have to be able to like link to multiple nodes, right? So this way here is saying, hey, I'm going to go from node 41, what is this? 416 million to 393 million to 150 million, blah, blah, blah. And so we're going to have to parse all of these and like draw lines for each of them essentially. And so I think to start, we should figure out how to use some sort of like XML parser. And so I was Googling like C XML parsers, and it looks like there's kind of two big ones that people use, libxml2 and xpet. And I think based off of like my very brief reading on both of these, it feels like xpet fits what I want more. I think xpet's like kind of like more like a streaming thing where you don't have to pre-process the whole file. It just kind of like as you go in one blast, and it will tell you like, hey, I just went into a child node called this. Hey, I went into this child node. I left that child node. Where libxml2, it seems like makes like a bigger, like a in object or in tree object where you can like navigate to things by paths. I think what I want is closer to xpet. I just want it to like rip me, like tell me when I have nodes, tell me when I have ways, and that's probably all I need. And that should be simpler, faster. So I was also looking up xpet example. Libxpet, sorry. I think I saw it in here somewhere. Examples here. And one of these was just like the fucking simplest of them all. Was it this one? Elements.c. Simple demonstration. Here we go. Okay, so let's just kind of start here. Let's fucking copy paste this, run it on our file, and then move on from there. Try to figure out how to like integrate with whatever we actually want to do. We probably need xpet in here. I don't know if it's gonna be libxpet or xpet. We can just guess and to wait for like 45 seconds for next shell to figure out. And while doing that, we can actually just look at the same time. Why not? Why not? Xpet. Looks like it's just xpet, so we did guess right. And we can say test.c, paste this shit in here, and let's just compile this thing and see what fucking happens. So test.c. He doesn't like that we don't have these symbols because we didn't link. And now we are chilling. So what is this fucking thing that we just copied to do? Who fucking knows? We could look. We could look. So he takes no arguments, and he creates a parser. He reads from some buffer. Oh, he reads into some buffer. Is one standard input? Is this just saying I'm reading from standard input? Probably. Fread, oh no, it's pointer size, number of elements. Okay. So he's reading one buff size element from standard in. I see. So here, maybe I guess we can test this by doing cat planet and pipe this into test. No? Doesn't look like he liked that, but maybe he doesn't print anything. Right? So how can we tell? How can we tell? Let's see. I guess we just run the thing in GDB and see where it's returning. Yeah, let's do that. So we can do GDB test. Undefined. Oh, he doesn't like this at all. Fuck. Oh god. He doesn't like that at all. Let's try. Wait. Oh, I switched windows. My bad. Give it a sec. Give it a sec. He's thinking. Let's change this to not read from stdin. I don't like the idea of reading from stdin. I like the idea of us passing the file on the command line and it reading it. It's possible that it's like maybe trying to like read way too much memory at once. So let's just adapt this a little bit. Okay, argc and argv. So we're gonna say if argc is less than 2, return 1 and fprintf to std error, not enough arguments. Okay, we'll start there. Okay, cool. So we see not enough arguments, so we are doing what we expect. And then let's say, f open. We've got to remember how to use C. So we open it, and then this gives us a file star, and then we can fread on it probably. So this is just going to be argv1, because argv0 is the process name. And we probably want like R, probably. Is it with quote strings in this language? I can't remember. They take in a mode which does look like a string. Okay, so I've opened this. So we'll say file star. This is called files equal this. And then wherever they were reading from stdin before, we can read from file. Okay. Cool. So zigcc test, and we run this on parse plan nid. Okay, so this is a good sign. We are seeing it print out nodes, and they're like at a current indent level. So we're seeing like node, and then indent tag. So this, I think that we saw when we were looking at this directly, we do see like nodes and tags. So that's a good sign. That is a good sign. Now maybe what we want to do is extract some information about this thing. So maybe we can do something like, instead of printing all the time, where the fuck they're doing that, can we change it to maybe we want to count how many nodes there are and how many ways there are. That will give us some like intuition about whether or not it's feasible for this data to like be uploaded to the client at all. I think it will be, but we should find out. Okay, so where are they printing? XML error string get current line. So this is an error log. This is the loop, main loop. I actually don't see the print. I don't know if I'm just like fucking blind. Like I actually am like very confused actually. So they parse the buffer. If the thing fails, then it start element, end element. Oh, good eye. Good eye. I see. So they set the element handler. At the beginning of the element, they print it. Here they basically say how far in are we in the depth, and here's their depth pointer. Got it. You guys are better at reading than I am, for sure. Okay, so here, let's just maybe count how many nodes there are. So they are looking at the name field here. So they have name and attributes. Okay, cool. So we can make it so that our user data, instead of it being depth, is going to be maybe like a struct user data. Fuck it. Parser data. And here we're gonna have like a size t of num nodes and a size t of num ways. And then we can just go in here and we can say, hey, we have this user data. This is gonna turn into a struct user parser data. Which is going to be a struct parser data star, parser data, boom. And then here we can say parser data. I guess we want a memcomp on name, probably. Man memcomp. So this returns integer less than equal to or greater than 0 if the first n bytes of S1 is found, respectively less than, to match, or greater. So we want 0. So we want like node and name. I guess this name is a string, so actually we probably want strcomp. And if this is equal to 0, we say parser data num nodes plus equals 1. Cool. 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 And then we want to do the same thing if else if strcomp way name is equal to 0, we increment num ways. Okay. So then at the end of all this, maybe we'll do like 100 iterations just at first. So int I equals 0, I plus equals 1. If I equals 100, break. And then we can test if this worked. So we can say, hey, let's look at the parser data. Printf nodes is this much, ways is this much. And we want to print data num nodes and data num ways. I think we don't want the arrow here. I think we want a dot. And we actually have to define data. So struct parser data is equal to zeroed out. Zero out that fucker and set the user data. All right. Let's see. And like this and like it's whatever. He doesn't like this because %d should be like LU probably, because it's a long unsigned close. Strcomp probably needs to be from like string.h. Cool. And if we look this, cool. So we did count a lot of nodes. We did not count any ways. Give him a sec. Did I spell way wrong? Oh, no, because we only iterated 100 times. So if we do this, and I want to kind of build and run this thing all at once. It's slow as fuck. Can we maybe run with optimizations? I'm not really sure like what order of magnitude. Like how fast we expect this thing to be. Release fast is not. Oh, I guess this is with ZigCC you need like 03 or something. 02 maybe. That's still really fucking slow. Maybe what we'll do is we will say if I %100, maybe like 1,000 even, we can do this print here. Then we can get some sort of like incremental progress. And we love incremental progress because our stupid fucking monkey brains cannot handle the fact that yeah, there we go. Sick. Looks like we are chilling. Yeah, our stupid monkey brains can't handle lack of progress. I don't know why it's just sitting here. Probably it's parsing a lot of relations at once. And we don't really give a shit about that. Okay, so let's just see hand wavy if we expect, like, if we got like approximately the right answer. So we can look, maybe do like grep part planet. Is it grep argument first? Yeah, and then we can, you know, maybe we want to look for an open bracket followed in the beginning of it. And then maybe we need to escape that thing. Cool. And then we word count, line count it. So is that what we counted? 3161503. Give it a sec. 3161503. Okay, so it looks like we're using the XML parser correctly, probably. And so we can kind of maybe stop thinking about this a little bit. I think we put this on hold just for a second, because I think that what we do next depends probably on how we are going to use this data, right? So I think that we have, you know, approximately, well, let's run this again just to double check. We have like a feeling for the order of magnitude of the data, right? So if we were to render everything that we have right now, we would render 488,000 lines, right? So we can do like a quick calculation. We can say, say each line goes, I like how I opened color paint because I just opened it so much. I meant to open a KCalc. So if we want to render, oh, okay. And I guess that there are also 3 million-ish nodes, 3.1 million. Yeah. So if we do 3.161.503, let's say that each node has 2 floating point numbers associated with it. So that's what, 8 bytes? That's 25 megs. That's actually not that bad, right? And then we will say that like each way is referencing 2 node IDs. Oh, I guess maybe more. It might be like line segments. Okay. Let's maybe look at planet. Way, I think. Oh yeah, so these are like multi-nodes. So I guess we could count these. We can count these. Fuck it. Let's count them. That's fun. Let's count them. So we can also just say else if we see node, we can say node refs plus equals 1. This becomes node refs. Boom. And we can just do this same fucking thing again. We have to log the number of references as well. So this is our refs %lu, and we get data num refs. Boom. I fucked up. No field named none refs. Node refs. Fuck. Okay. He's thinking. Okay. So we have just under 4 million node references. So let's just say kind of hand wavy 8 million. I guess it's going to be 3 million ish times what we said, like 2 floating point positions. So 8 plus 4 million times, let's say that each of these need to index into a 3 million element array. So let's just, does that fit in 32 bits? 2 to the power of 32. Yeah, by a lot. Of course it fucking does. What about 16? No. So we need 32 bits, so 4 bytes for the indexes as well. Okay, yeah. So 3 million-ish times 8 plus 4 million. Fuck. Okay, so maybe like, I'm not 100% sure I got that right. So 3 million times 8 plus 4 million times 8. Okay, so like 56 meg-ish of data, which I think is like totally reasonable in terms of like what we are capable of drawing on our GPU. Like 56 megs is not a lot, right? It's a lot if we were going to try to like draw this on the CPU. That'd be like a fuck ton. But if we want to draw this on the GPU, 56 meg, not a big deal. Textures are way bigger than that, right? Like when you're like playing video games, you're like, I have 8 megabits of textures loaded all the time. So I think this is probably fine. And so I think that like probably my gut here says that what makes sense is to basically just use OpenGL or WebGL, I guess, to just render this. Because I think that what I'm going to want to do eventually, is run all of this stuff client side because I think it's more fun. And I probably will want to render it on my phone as well. And so just having a website that I can go to on my phone and take 56 megabytes of download, we might have to reduce that somehow. Or maybe we will like cache the data so there's only 56 megabyte download once or something. I don't know. We'll think about it. But I like the idea. So yeah, let's figure out how to draw anything with WebGL, and then we can kind of come back to figuring out how to like structure this data in a way that we can parse in the web client. And then of course we're going to be doing it from WASM because you know, I like writing Zig. And I think that like cranking through this much data is going to be much faster in WebAssembly, to be honest. Okay, so we can do our typical start up a second thing so that we can serve some data with Python. We will then maybe write like a little index HTML. Was it doc type HTML? We put everything in an HTML. And we need to close this brace probably. Here we need to say that we have a head. And we have a body. Our body says, I am a body. And our head says, I would like to import some script. Right? Like this. And then we're going to have index.js. And he's going to say, I am a JS, I guess. Here we will Python HTTP server, and we should be able to get the fuck over there. He is a body. He is a JavaScript. Chilling. Big chilling. Okay, so I think what we want to do here is we want to get like some sort of like WebGL thing. WebGL. I'm like, you know, vaguely familiar with WebGL, right? Like or OpenGL and stuff, right? We've done a few OpenGL things here in the past. So I kind of get how I expect it to work. But I don't really remember exactly how to use it in the browser. So let's just kind of skim through these things and we'll see what they tell us to. Okay. So he makes a canvas. That is what I expect. He asks the canvas for a WebGL context. Ship it after saying I am a JS is very funny. Good one, you guys. Oh, okay, and then so yeah, we can start here where he just like creates a canvas and clears the color with WebGL. I think that makes sense. Let's just take a little peek skis and see if we can do that at the very least. So here, canvas, we're gonna have like a width is 800 maybe, and our height is gonna be 600, and from JavaScript, we're gonna do like, I guess maybe we don't need an async function in it, but I'm used to doing this, so I'm just gonna do it anyways. And I don't know if this is like if this is what I'm supposed to do. I don't really know that either. I don't know. It's just I did it one time and it worked, so we live here. Let's make sure that this init function does in fact get run. Hello, he says hello, so we are getting run, which is a big win for us. And we can just say const canvas is equal to document get element by ID. Canvas. We didn't actually give him an ID, so we should probably give him one so that we can identify him in some way, shape, or form. And then we're gonna say canvas get context. Was it WebGL? I think. Then we say GL is equal to this. I think I saw them do like an error check. We'll write like Sag here. And then here we can do like, what do? They did a clear color. They set the clear color and they called clear. So that's a 0001 for a fully black screen and GL clear with the buffer bit, color buffer bit. Okay, so this matches kind of like my expectations around like OpenGL as a whole. This feels like what I've seen before. Triple equals. Dude, fucking JavaScript. What? Oh my god. You should replace the maze with the vacuum just going metal on a bunch of balls. We are going to replace the maze with the ball machine eventually. It's just not quite there yet. Okay, so that is an 800 by 600 canvas with a black box. And if we just do something like I want it to be green, we don't have to do any kind of code compiling, but we are chilling. We're chilling. Okay, so now let's continue on and see if we can figure out how to draw like a triangle. Okay, so that's done. Adding 2D content, blah, blah, blah. Okay, so they make a vertex shader. They make a fragment shader like you would expect from any OpenGL world. For those of you who are not familiar too much with OpenGL, the way that this stuff usually works is you kind of like define like points and you ask OpenGL to like draw you a triangle from these points. Well, you can ask them to draw whatever. You can ask them to draw triangles. Sometimes you can ask them to draw like line strips, triangle strips. So if you were to do, you could do something like, I'm going to define points like this. And you can ask him to draw a triangle strip, and he's going to draw kind of like this for you. Then what happens is you define like a vertex shader. Your vertex shader, calling it a shader is kind of a silly word in my opinion. I think it's like a relic of history. But shader just means code running on GPU. And the code can run per, I guess we call it like element. I don't really know how like the correct terminology here, but I'm just making stuff up. But basically your vertex shader says, hey, I have like a point here, here, and here. I'm going to run this vertex shader for all of them. And so if you're in your vertex shader, you say like, I'm going to subtract all of the positions by 5, right? They will all move this way. And you'll kind of draw your thing over here instead of over here, right? So that's the idea of like the vertex shader. The fragment shader says, okay, I'm going to run for each pixel, hand wavy. Hand wavy, we're going to run each pixel. So the fragment shader says, hey, for each pixel in this triangle that I drew, I'm going to ask you what color to put in this pixel, essentially. And so that's what you are basically seeing them do here. They're defining a vertex shader. This vertex shader, they're putting a bunch of stuff in here that we don't really need. But basically, it's just you set this GL position thing to match some sort of like input thing. Then they have a fragment shader, and here their fragment shader is just saying, make it white, please. I'm going to make the output white. And I believe the minimal OpenGL pipeline is a vertex shader and fragment shader, but you can have like other shaders in there as well. Like there's things like geometry shaders that let you like generate vertices on the fly and stuff. We don't need that either. We don't need that either. So I think that we're probably going to start by copying something that like is similar to what they're doing here. How do I want to do this? Probably show it here. I don't really care about their uniforms. So uniforms are kind of like global data that you can set for all runs. So like for each vertex, this is going to be a like individual, like unique per vertex, kind of. This is going to be like the same for all runs. And they're basically saying like, hey, we might want to like apply some transformations on our inputs. I'm telling them, shut the fuck up. I don't want to do that. So we're just going to say, hey, here, vertex shader, we're going to have an input thing, and we're going to set the output to the input. Simple. Simple, simple, simple. And we will copy their fragment shader. Their fragment shader seems reasonable. Their fragment shader is just like, white, please. White, please. And I assume that somewhere they then compile these into a program, so they call load shader. Is load shader something they define here? Yeah, it is. Okay. I'm okay with copy pasting their load shader for now because I don't really want to think too much about it. They create a shader, they set the source, they compile it, and if it doesn't succeed, then they delete it. Okay, sure. So this is kind of funny too. This is very manual managed memory, which is funny from a garbage collected language, but whatever. Okay, so they create a vertex shader, a fragment shader. They create a program that like links those two shaders together, and we should be chilling. Then they check if the link failed, and if the link failed, we're in big trouble. Which is fine by me. Okay. Okay. Then do they actually do this? This is all in a function they called init shader program. I see. So their init shader program here. So where do they get the source? So this is VS source, FS source. These are named correctly already. And I guess we can kind of just run this now and see if it at least runs. It looks like it doesn't. It looks like we have fucked up big time. 71. It looks like we have mismatched our braces. We forgot a closing brace here. Okay, so the fact that we got to the end here is indicative that nothing threw, which I think is probably good for us. Because this thing, we at least didn't get any alerts. We didn't get any alerts, which is good. Webgl actually runs on the GPU. Depends on what you mean by runs. But yes, the code in these vertex and fragment shaders should run on the GPU. Now, if your GPU is shit, like if you there's like also like integrated graphics and like software OpenGL, but like generally, yes, generally this will be running on the GPU itself. And like the reason that you have like your program runs on like a per vertex basis is because like GPUs are massively parallel, right? And so the way that this works is that you can run for every single vertex in your whole program like in parallel at the same time. Boom, it's fucking done. Which is a big win. And you can definitely abuse that for stuff as well, which is pretty fun. But we'll get there in the future, maybe. Maybe we won't. Maybe she's born with it. But jeez, okay. Gotta stop referencing this one commercial I saw when I was like 8. Like nobody else is gonna know what the fuck I'm talking about. Okay. So we have our shader. Here they create the vertices of a square. So this is 1, 1, -1, -1, 1, 1, -1, 1. Okay, so they're grouping them by twos. They're grouping them by twos. And then they are saying, hey, OpenGL, I would like to give you this data. I would like to attach it to this position buffer. So they get a position buffer, they bind it, they say, here are the positions, and I would like to draw those, please. Now I'm a little confused because their vertex shader said that they were taking in vec4s, but their position data that they are drawing here only has 2 points associated with each one. I also remember somewhere you're supposed to set like attributes. So if I remember correctly, you do something like you have like buffer data on the GPU, right? You say like, hey, here's my 1.0, -1.0, 1.0, 1.0, right? We like, and these have to get mapped into this vec4. And so I remember having to do something that says like, hey, the first I have a 4 points here, and they are at position 0, and they come every 4 positions. And that's called like attributes. So probably they've just done that here, and I just wasn't looking. Okay, attrib locations. The position. This is this is them uploading this like the data. Where do they like tell the thing where it goes? Set position attribute. This looks promising. Aha! 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 Okay, okay. This is what I was looking for. This is what I was looking for. So they say, hey, we have 2 components. Okay, so vertex attrib pointer can like basically cast a 2-dimensional vector to a 4-dimensional one. That's probably what's happening here. Vertex attrib pointer. Size specifies the number of components. Must be 1, 2, 3, or 4. Yes, yes, yes. Okay, so if I say that it's only 2 components, but my shader takes in 4, OpenGL will do the work to like understand like, okay, so we'll just 0 the other 2 components or something. Okay, cool. Cool. So let's try to do what they did. So let's create a buffer, bind the buffer, yoinkies, like this. Okay, we create the position, we create the buffer, we bind data to the buffer. Big win for us. Then where was their set attributes? Here. Set attributes. They queried the location of the parameter that we care about. We can kind of just say that it's probably 0. I'm pretty sure that that'll work. Although we will find out in a second if I'm a fucking idiot and it doesn't. But I'm pretty sure it will. And then we'll copy paste these constants from them as well. Then they enable the vertex attribute array. Okay. And this is 0 for us. I guess we'll name it const vertex attrib equals 0 or something. And then here we can say vertex attrib and do it here as well. We're really skimming through it. Okay, it doesn't crash, which is really good for us. It's really good for us. Now we can try to actually draw it. So what we have to do is once we have all the data on the GPU associated with a buffer, we have to actually bind the program that we compiled and run it. So this is what we want. We want to use the program. After we clear everything to green, we are going to make the program. We called it shader program. So this is shader program. They ask us to draw a triangle strip. Perfect. So I think this should be fine. We might have to rebind the data. I'm not 100% sure here. Let's just see what happens when I refresh. Something not good happened. Oh, because our points are filling the whole thing. Because we didn't apply any like change them. So can we just like change every 1.0 in this list to like 0.5? Oopsies. I keep expecting to have to recompile. Okay, wait, that's really good for us. That's really good. Okay, so what we did is we have created 2 triangles on here. And we have successfully drawn a white triangle in here. We can prove that by changing this to like the vertex, the fragment shader will tell it to render blue instead of white, and that turns blue. So we have the ability now to draw a thing from the GPU into a canvas. And the rest of the stuff we can figure out on our own. I don't really feel like we need more of this like copy pasting from MDN. It was mainly just I was looking for like the APIs to things I already know. So simple. We create our program based off of these shaders source things. We compile, we link them, we create a program. We create a buffer where we embed positions in our like 2D array. And this part was something that I needed to look up, which is that you can like cast data as a float32 array. So I'm kind of curious about how this like GL buffer data call works. Because that does not look like the C version of that looks a lot different. Right, the GL buffer data in C, I guess it just takes in like a pointer and a size. I don't really understand why this version is using a float32 array. I would have expected a uint data array here, but it might be something a little bit intelligent here. They might be doing something clever. Okay, so source data is an array data buffer, shared array buffer, typed array, data view. They'll be copied in the data store. Okay. I guess like they're like deriving the length and stuff from this, right? Like the C call is target, size, data, usage. So it's probably something like if you construct a float32 array from these, it will like leave them as float32s. Probably if we did like uint8 array, it would do something stupid like cast these to uint8s. And then the length of this thing has to be like figured out based off the fact that they're float32s and the array list is long. So it kind of makes sense. It makes sense. Sure. Then we like basically tell the GPU, hey, this is where everything lives. With this. And then we use the program, we draw stuff. Okay, pretty straightforward. Now, what I want to do is I want to figure out how to fucking make this shit work from WebAssembly. Because when I've done this in the past, I used like Rust. I've done WebGL and WebAssembly a bit in the past, but I use this like bindings library called Glow. And so like there's all sorts of like levels of indirection here in like that world. I think my mental model now, it could be wrong, right? I'm kind of like making this up based off what we've learned recently by doing like the ball machine stuff. I assume that what happens is you have like Glow and like compile shader or something, or let's look for like a specific call from here. Let's say use program. I think that this is like Glow, and he binds to like WebSys, which is like Rust interop with like JavaScript APIs, which will like kind of I assume have some sort of like, you know, Rust.js thing that's generated where he kind of feeds individual OpenGL calls back into this guy. And so probably what happens is like for every single OpenGL call, you're going through this like this bindings layer, probably something like that. So I kind of want to see like what would I do if I'm gonna say, instead of doing whatever the fuck they did, we're just gonna we want to provide something from WebAssembly. I don't really know what. I don't know like at what layer we want to do these bindings, I guess, right? Like if we were to say we probably want the shaders to be defined by WebAssembly, something that I'm like keeping in my head right now. Sorry if I'm scattered a little bit. It's because I'm trying to think about lots of things at once. But I want to keep the ability to render this stuff with like a real OpenGL context later if I feel like it, right? And so the question kind of becomes, what's the easiest way to support that? And so something like keeping the vertex shader source in JavaScript, I think would be silly. I think putting that into Zig makes more sense. The other thing I want to do is make sure that like I want to push as much into Zigland as possible because I hate writing JavaScript because I don't know what the fuck I'm doing. Right? So we need to have some sort of balance of like JavaScript, like maybe like JavaScript can do batches of actions if we want, right? We could have a function that's called like compile and link program. That's totally fine by me. And he just kind of does like all of this stuff. We don't have to bind individual GL create program, GL attach shader, GL attach shader, GL link program. We don't have to bind each of those individually. So probably we're going to want all of this like program compilation stuff to be in one thing, but we'll provide the shaders from the Zig side. That's kind of how I feel like it makes sense right now. For like the buffer binding stuff, we're probably going to want to say this data will probably be owned in WebAssembly land, right? Because like when we're working with the nodes in our OpenStreetMap data, we're going to probably parse that on Zig side. So it makes sense for him to own this buffer. So maybe we could say, hey, bind an F32 array. That probably makes sense. We can probably kind of like chunk all of this into one JavaScript call. Maybe this as well, right? We could maybe even say, hey, we are going to give you a list of floats that we expect to be this stride. And then we can kind of chunk all of this together. Because I don't think that we're going to need, I think that like since our data is pretty fucking static, it's not like we want individual access to the attrib pointer and the buffer, right? Like I think the reason that you would want individual access to these things is if like you're updating the data itself as you go, but we're gonna like upload the data one time and then just be like fucking done with it. So I think we can probably just say, give me all of this stuff back at once. I have to double check. So there's like the concept of like a vertex array object and a vertex buffer object. This is like raw data. And this is like data to variable mapping, kind of. Right? So when you're in your like vertex shader, where does this vec4 come from? That's kind of owned by the vertex array object. And I can never remember if effectively I can forget about the buffer once I've connected it to the array object. We can maybe look that up. Let's see. OpenGL array object. Array object stores state need to pass the vertex data. Note that it merely references the buffers. It does not copy or freeze their contents. And if those buffer contents are referenced changed later, these changes will be seen when using the VIO. Okay, that makes sense. What I want to know is if it auto binds the buffer. Right? Because like here, when we upload the buffer data, we bind the buffer. And then here, before we use the program, we have to make sure that it's bound like this attribute array. But I can never remember if it auto binds the buffer. Alexa's saying, I believe it does, which is my guess as well. But I would like to see something that says that. VAOs have the usual creation, blah, blah, blah. Binds this to the target. It does not auto-bind shader programs. Yeah, that makes sense. I wouldn't expect it to. VAO object is not 0, blah, blah, blah. You should call any... Okay. That's fine. That's fine. I guess we will work under the assumption for now that it does. Because if it does, then we don't need to keep track of the buffer object at all, which is kind of nice for us. Okay, so let's make a function that's like compile link program. And this is going to take in vertex shader source, vertex source, and fragment source. Oops. And in here, we're essentially just going to kind of do all of this shit. Whatever we did here. Oh, fuck. And this will just return the program. Return shader program. I don't know what the fuck is up with the indenting here, but it looks like it's okay. So then down here, we can just say const program is equal to compile link program with VS source and FS source. And I think it was called shader program before. Let's just rename this program. I feel like that feels nicer to me. And we can just refresh and see if it still works. It does not because GL is not defined. That makes sense. So here we need to take in a GL as well. Maybe what makes sense for us is just to make GL a global. Because I don't think that we want to have to pass in GL from like our WebAssembly context later. So we're just gonna like at the beginning of init assign that global, and then we should be chilling. What's he mad at now? What the fuck is going on? Hello? Why doesn't it fucking like I don't understand? There's something like wrong with my development setup. I feel like because like it's supposed to like I don't know why I'm not getting like breakpoints. It's pissing me off. Pisses me off. Okay, vertex source and fragment source. Okay, there. We're back. We're back up and running, baby. Okay. So that's one section out of the way. Then we want this like function make bind 2D float data. Bind 2D float 32 data. This is going to take in a data. Well, eventually this is going to turn into like WebAssembly stuff, but maybe for now we start by just taking in the positions. And then we'll kind of adapt this into WebAssembly stuff later. So this position stuff is now going to be like externally created here. As much as I love Firefox, the Chrome DevTools just work better. I could see that, but I feel like they didn't used to feel like shit. That's why I'm like annoyed. You know? But yeah, I could see it being true. Okay. So here, let's just return vertex at where is our vertex attribute pointer? Does this not return on like an array object? I thought it was supposed to like create like a vertex array object. A newly created. Do I not have to like create one of these? Gen vertex arrays. A newly created blah blah blah. Yeah, so do they not have like gen vertex arrays? What do they call to create a create buffer? So do they have like create array? Create. I'm a little confused about that. I would expect them to have like generate these things. Bind buffer, enable vertex attribute array. A vertex position. I guess maybe they're kind of like automatically tying them to the program as well. Yeah, I'm a little confused. Elect in chat is saying that they have gen vertex arrays, which that's my recollection here as well. But it doesn't look like the like am I fucking stupid for not seeing the equivalent in Webgl? You don't need these functions. You can just file without them. You have to bind buffers and use GL attribute pointers, and it's like before. Oh, so I see. So instead of us saying we're going to remember these sets of rules, we just have to reset them every fucking time. Okay. That's a little annoying. A little annoying. So how do we want to manage that? The fucking maze crashed. It's very important. It is very important. Very important. Okay, so I guess the correct answer here is that we need to make sure like this stuff has to be attached to the rendering almost. So here we will return. Okay, first of all, this program stuff wasn't supposed to come over here. This is supposed to be down here. This this will just bind the data, I guess, which means that this is just going to be bind float data. It doesn't even know about like the setting, and I guess we're just going to have to expose this function directly. That's kind of the only way, right? If WebAssembly, is that still true? Answers from 2012. Yeah, I guess you're right that we should double check that. Create vertex array. Okay, wait, yeah. Thank you. Good double check. So here we'll say GL create vertex array. Perfect. This is what I want. Hello, what's happening? Const val is equal to this. Then we can bind the vertex array. Probably. Yep, val. And then we can return val after we do all this shit. There we go. Nice. I thought it would be a good two-vote question for ChatGPT. It probably was. I agree. Am I supposed to unbind this after? Sure. Just to make sure that like nobody fucks with it. Fuck it. If it's only us, who cares? Okay. So now we can bind 2D float32 data. Bind 2D float32 data from positions. And this is const val is equal to this. And then we are chilling. Then this stuff we will just call render. Hello, X over this new project. Well, glad to hear it. Me too. So here, us having a single render function is probably so what's going to happen? We are going to externally from Zig, probably we're going to compile link the program. We're going to bind the data. Maybe we will, I guess we'll probably clear every frame. It kind of feels like this should kind of live in Zigland, to be honest. So maybe we'll call this render, like, what are the inputs of draw arrays? Draw arrays. Mode first count. So we'll just create our little... Oh, we actually don't even need to create a function that wraps this. We can just pass GL draw arrays directly in the environment. Sure, so we'll do that. So this will get bound, this will get bound, and I think both of these getting bound makes sense. Okay, we'll call it there. So we'll say, let's make a WebAssembly module that we instantiate, and then try to call these callbacks from there. So let's make a little index zig, and we'll make a function that's like run here. Pub export function run. And he's just going to do basically everything that happens here on init. So we're going to take like this stuff here, and we'll kind of figure out how to adapt it. So Zig multi-line strings look like this. So we'll kind of give it the same treatment. We have our vertex source, we have our fragment source. We want to call compile link program. So this is going to be external function called compile link program, and it is going to take in a vertex shader, which is going to be a const-u8. I guess it's going to take in a vslen, which is a usize, and then a fragment shader source, which is going to be a pointer to a const-u8, and a fragment shader line. Probably. I wonder if we can like live with null termination. That's also possible that that'll just work. But I don't really want to have to like search for null terminators in JavaScript and stuff. I think it's easier just passing the lengths. Fuck it. Blaze it, you know? Shut the fuck up, man. Why the fuck? I shouldn't just say blaze it like that. Fuck off. Okay, bind 2D float 32 data. So this is going to take in like data, which is going to be a bunch of float 32s and a data len. And it's YOLO. Dude, I said YOLO so much back in the day. Holy, YOLO was my favorite. What a fucking stupid word, but fun. Okay, so we're gonna call bind float32 data, and so now we can say that our positions are gonna be something like this is gonna be like a slice of const float32, and this is gonna replace like it's gonna look like this in this language. Well, okay. Then we're gonna ask to clear the color, so we're gonna have to have some function like clear color, and this is gonna have like RGBA, which will let us call clear color like this, and then we're gonna want like clear as well. And this is gonna have some sort of like mask. Some sort of mask. I don't know what the type of this is. Clear, 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 clear. Mask. GL bit field, which I think is just like an i32. And maybe we will call these like GL, like they kind of are the OpenGL equivalent calls. So this will be GL clear color, GL clear, and then we want use program. And it's going to take the program ID like this. So then we can call GL use program with our program, and this stuff is fine. Cool. So we just need draw arrays now. And this is going to take in like what are the actual types of that thing? What are the actual types? Mode is int first int. It's all ints. Mode first last. Maybe these can be U32s. I don't really know how like the binding of like WebAssembly signed to unsigned types works when they hit JavaScript. I'm not really positive about that, but hopefully we just don't have enough data that it matters. I don't know where. Probably we want to steal these defines from somewhere. Color buffer bit. Like, how do we get the? How do we get like the integer value of it? How do we get the integer value of GL color buffer bit? We could like yoink it from some like OpenGL header, but I don't really know if we can assume that it's going to be the same. You could maybe just include the C header and zig. That's what I was thinking, but I don't know if it's like safe to assume that like WebGL isn't like adjusting the values. I wonder what Glow does. Fuck. Like, how do they do it? How do they do it? Like, do we have color buffer? So this comes from WebSys. Color buffer bit. Yeah, okay. And they just have these like hard coded. Okay. This also talks about like WebGL2. Was I supposed to ask for a WebGL2 context? Maybe not. We'll find out. We'll find out. Okay. I'm okay with maybe just yoinking the define. We might have to come back and think about this a little harder later, but you know. What is this? There's no reason to do that, right? Because Little Indian? I think it's totally fine. So I think we just comp time int, we'll call it. Okay. So we'll clear with color buffer bit, and we'll need triangle strip as well. Yoinkies. There's a good chance that this isn't okay, just for the record. But we will figure it out. Triangle strip is 5. We'll say yoinked from WebSys Rust definitions. Cool. How can you replace the Google map? Top right. Top right. And if you're still confused, then we can figure it out from there. We need to have a pub extern function that's like bind val. What is it? GL bind vertex array? Yeah. And here we'll take in the val as an i32. Okay. Okay, so this should be everything we need. So we create our program, we create the vertex array, we bind the vertex array, we clear, we use the program, we draw the arrays. With great difficulty. Yeah. Well, we'll see. Maybe it won't be too hard. Maybe we'll be pleasantly surprised. Okay. I like seeing a fellow Vancouverite use my favorite language to replace Google Maps. Well, glad to be of service. Okay, we're gonna move index.zig into source because I want to make a build.zig. Because I don't want to have to type the commands over and over again. So I think it takes out a function build, it takes in a std builder, std build, like this, if I remember correctly. And maybe we just go to the ball machine and we try to yoink out our build definitions for WASM. This looks promising. WASM target is this. Okay. What else is in there? We have like build WASM exe maybe? Yeah, here we go. Here we go. This looks like what I want. This looks like what I want. Okay, so this is a this will come down here. We'll set these parameters on our executable. Our executable is going to be created with this shit. So we're going to say, hey, I want to use our builder to create an executable of name index. Our root source file is going to be source index.zig. Okay, we are going to use the WASM target and we're going to use the optimized flag. So we need to say const opt is equal to builder like standard optimize option with no parameters that I care about. I think we have to not void. We put a dot here to indicate that's a resolved type. And then this is going to be called const exe. And then we have to install the executable. So it's like b install artifact exe. Should be good. Should be good, but we'll find out. We'll find out in a second. He's not happy. Compile link program expected 4 arguments. That's fair. That's fair. We did say that it would take 4 arguments, so that's on us. So this is going to be take the address of VS source, and then we say VS source.len, and then we take the address of FS source. We say FS source.len. Now in Zig, these should be camel case, to be honest, or not camel case, snake case. Sorry, because that is the way of the Zig people. Often I want to say that it is like, I don't know, maybe it's just wrong. Part of, like, I feel like I want to say, suffix the word with ers, as like the people who do this thing, but with Zig as the prefix to that, it sounds very bad. So maybe I should say Ziggians, the Zig people. That feels right. We can pretend they're a population instead of saying something that sounds a lot like a slur. Ziggerites. Oh, that's still too close. It's still too close. Zigglers, still too close. All of these things are very close. I'm gonna say Ziggians. There's no possible way to misinterpret that. I think I'm gonna say that. I'm gonna stay there. Okay. It does look like he doesn't like this, because he expected a pointer to some U8s, and he found a pointer to U8s. Oh, okay, so I didn't realize that this stuff comes in as slices. So, like, this should be fine? Okay, bind 2D float data. He also needs to give the same treatment where we have positions len. Okay. He expected, here we can write const so that it's okay to use compile time data here. I don't understand why this doesn't work, to be honest. Expected, oh, because I have to write dot pointer here. Uh-huh, yep. GLU's program needs to take a program parameter. So when we created our program, did we not return either G? We did not, so we have to do that. And now this compiles. Zig stations just to piss off two groups of people at the same time. I like that. I like that. It's like so stupid. It's so stupid because crustaceans was also a really bad word. Like just like not a good, like a reasonable name. Or like it's just like kind of silly. So saying Zig makes even less sense there, which I find very funny. Okay, so now in order to use this, we are going to have to import, we're going to have to like define these functions and import them from JavaScript. But maybe before we do that, maybe it would have made more sense to get like a little hello world working here first. So maybe we'll start there. Let's just do a little simple add that takes in A and B and returns C. And then before we get into any of this crazy stuff, we can make sure that we can like instantiate and load a WebAssembly module, because I think that's important. It's important that we see incremental progress. We love incremental progress. I'm begging you to use a code editor copy pasting. Yeah, is it bothering you for some reason? I can't see why. I can't. Okay. WebAssembly instantiate streaming. Okay. We instantiate streaming the object. So here we are just gonna like WebAssembly instantiate streaming, fetch from Zig out bin index Zig, I guess is probably where this is gonna be. Import object, we're gonna start empty. And instead of doing then promise chaining, which I find a pain in the ass, we're gonna say like await. And we're gonna say mod is equal to this. We're gonna install mod instance exports add 1 2. And we're gonna console log that. And hopefully, if everything is in the right spot, we should be able to refresh this page and see a added thing. But instead, he can't find this, which I thought he would be able to. Index WASM, I'm a dumbass. Okay. Okay. And I guess we don't have to recompile anything. Okay, so create vertex array is not a function, but we did see this run with number 3, so that's good. So where is this complaining? Create vertex array is not, maybe I have to ask for Webgl 2? There we go. Okay. Okay, we're back, baby. We're so back. We are so back. Okay, so now we can go back to our index Zig, and we can start uncommenting this stuff, and we'll just see, does this like still instantiate correctly here? It looks like it does, surprisingly. I would have expected it not to instantiate correctly because all of these functions are not defined, but maybe it's just because JavaScript is just being like generous to us. It'll probably crash here if we try to run here. So here we can say run. I guess we first have to get the GL context, but then once the GL context is bound, then we can say mod instance exports run, and we can expect this to crash in some way, shape, or form. Right, because run is not a function because we didn't compile. Now it is, but the import field is now missing. Okay, so now we have to say env. And we start by making it empty. We refresh again. Env is not an object. Is it like env like this? Is that how you're supposed to do in this language? Am I missing something really obvious here? Import object env colon functions. Why is it saying that env is not an option then? Am I stupid? What's happening? Oh. Right, because I am an idiot. I'm just sticking in the wrong fucking spot. I want this attached to this. There we go. Okay, compile link program is not a function. Okay, so we're getting closer. So now we just have to define all the functions that we wanted. So is it by how, do we have to put strings anywhere? No, it's just the compile link program. And he expects something. He expects compile link program takes in some pointers and some lengths. Okay. So here we're gonna have to set like memory as something that is like accessible globally. Before we call the run function, we are gonna initialize this thing. We're gonna like export the memory. So here we're gonna say memory is equal to mod instance exports memory. Now we can like look at the WebAssembly memory when we call compile link program wasm. And this is gonna have to take in like whatever we said it was gonna take in. So compile link program wasm. He's gonna take in the source vertex. It's like vs len fs len. That's what we said. And we're gonna have to like look at the data that's been passed in. So it's like new uint 8 array or something. We're gonna say, hey, we are gonna look at the data from the WebAssembly memory, which is capital I, int is I is lowercase. And this is gonna have like from the memory buffer, I think it's called. We're gonna look at vertex shader and vertex shader len. So this should be the VS source. Then we can say the FS source is the same thing, but with FS and FS len. And I wonder if we just call compile link program with VS source and FS source like this. I'd be curious to see if that works. And probably what is the intelligent thing to do here is go back into our Zig land and try to like maybe just not do the rest of the function. And hopefully that kind of means that this will run here. Missing equals in const declaration. That makes sense. He's a little whiner, this guy, huh? A little bit of a whiner. He's like, hey, could you please maybe like use the fucking correct data types? Syntax error. Syntax error. Okay, so it's hard to know if the syntax error is because we were supposed to pass in like actual strings. So we can try decoding the text here. We can say a text decoder. I think it's UTF-8. We can say like deck is this, and we can try calling deck.decode VS source and deck.decode FS source, just in case that it's expecting strings here instead, and it is. Okay. So we have the first thing out of the way. The first thing out of the way. We can go back into index Zig, and we just start moving this if true return down a little bit. So now if we run this again, he should get mad that bind 2D float 32 data is not a function. So here we need to add that to our import objects now. So bind 2D float 32 data. And what is this guy gonna do? We already have something that takes in like an array. So we just have to do bind 2D float 32 data wasm, I guess, just to follow the convention. And then here we'd say function bind 2D float 32 data wasm takes in the data and len, I think is what we said here, right? Data and len. Cool. And he returns an I32. So here we're going to call new float 32 array from the memory buffer given data and len. And then we kind of just can pass this thing directly into here. Can you iterate on the GL object and just copy paste every function into your env? That's a good question. That is a good question. I don't know. I don't want to do that, but it's kind of an interesting idea. It's not a crazy idea. Not a crazy idea. But I think I'm not going to do that. But it is interesting. So here we want to change this so that he doesn't have to create the float 32 right here. He's just going to use it directly. And then this guy is gonna have to say new float 32 array like this. Now everything should be happy. Good. Everything's happy. And now we just kind of keep going. Keep going. I think we can probably do the rest of these like almost in one shot, so I'm not gonna worry too much about slowing down here. I just want to make sure that the GL binding happens before we try to do the instantiation. And then here we can just start like ripping it. So it's GL bind vertex array takes in a vow and return is just GL bind vertex array. Vow. GL clear color takes in RGBA and calls a clear color with RGBA. Clear takes in the mask and runs clear with the mask. I guess here we don't even we can just do GL clear color dot bind GL, right? Is that simpler? That feels clearer to me. Right? GL use program and draw arrays. GL draw arrays. Draw arrays. Okay, so now if all of this is done correctly, if I comment out all of this, we should see the same square rendered. I mean, the chance that we did this right is slim. That would have been cool. But he doesn't like this because argument 1 is not an object. What the fuck? Does this work if we breakpoint here? Bind vertex array. Yeah, is that not what we did before? GL bind vertex array VAO. And we take the VAO and we return it back. Oh, here we probably have to return here. It's probably related. Argument 1 is not an object. Why not? Why not? Can we console log val here? It says 0. Argument 1 is not object. So what is it expecting? What is it expecting? A vertex array. Oh. This is not just a number? Is bindGL like returning a function, like currying? Yeah, I think it's supposed. My understanding is that it is currying. So it could be that this thing, when we return it, is not a number. Can we like, what is it here? Because if it's not a number there, that makes my life so much fucking harder. Oh, what a pain in the ass. What a pain in the ass. So it's like, it's not just an int. It's like a thing. So returning this thing into JavaScript or into WebAssembly is gonna suck ass. Does it even have like data? Ugh. Okay. So maybe what we do is we have like vows. And then here we push. And then we return like the index. Okay. Which is a little silly, but that's fine. I guess this kind of happens. This can return the object directly here, and then we'll kind of do this in like the WASM side. That's fine. That's fine. Is there some sort of constructor to create it? It does have like a constructor. I don't know how to read this. I also don't really see it documenting a constructor here. So I think I am just gonna like do this. And then when we have like bind VAO here, we're gonna say vows vow, which sucks. But that's okay. We don't free anything ever, so it's actually fine. But we will have to adjust this to be like hash maps later or something if it's a problem. So use program has the same thing. So bind use program is gonna here take program and run programs program. And then when we create the program, we're going to have to say programs push program return programs len -1 length, which, you know, it's fine. We'll make it work. It's good enough. Good enough for now. Okay, so I think that this is now doing everything from the WebAssembly side. We should be able to go back into our index.zig. We should be able to change this color to like red. And that turns red. And we should be able to turn like the clear color to like, you know, yellow. And see that turn yellow. Okay, so that's a really good sign. We have like the ability now to upload arbitrary data, right? If we want to do, like say we only wanted to draw 1/2 of the triangle strip, we can do that, right? So we're kind of like in a state now where we can, from Zig, render whatever we want. And now all that's left is to try to render the map data. So what we should be able to do is let's first change this to, instead of doing a triangle strip, let's try to make it render lines. So we can just look at lines. Kind of yoink this thing. Or we probably want line strip. This is probably more along the lines of what we want. So let's change this to a line strip. We build, we refresh over here, and we do see a line drawn now instead of a triangle. So this should be a pretty good like thing to work with for trying to draw streets on the map. Okay. Let's do that. Let's try to render a map. So I guess maybe we're going to change this to say we're going to start by pre-processing the data for Webgl. And so I think what we're going to do here is we're going to basically just walk the nodes. Maybe we just start by walking the nodes. Let's just render points. Fuck it. Yeah, let's render points. So let's kind of find the definition for points here. We'll try rendering points. So this is points is 0. And then here we say GL draw arrays points. Let's see if that feels like it works. We have to build our code if we want to run it. Turns out, I think that they are there, but we have to change the point size. So we can do like GL point size like 5. I don't know if this is supposed to be an int or a float. GL float. Okay. So we'll say we want a GL point size that takes a float. And we have to bind that in the JavaScript side. So here we're going to say we're going to have GL point size is GL point size. We're going to assume that that function exists. It might not, but we can just kind of find out real quick by just running it and looking. He does not. So GL point size WebGL. Maybe WebGL expects us to use the shader attribute. GL point size. This comes out of the vertex shader, so we can try that instead. We can try that. So here we just say GL point size equal to 5.0. Maybe. We'll see what that does. Oh yeah, there we go. Let's make it even bigger. Let's make it even bigger. Have you tried Zig Build Watch yet? Just dropped it a few days back. No, I have not. Okay, cool. Cool, so we have some points. We have some points. And so now if we just walk all of the nodes, I should, like, I think that I'm on an old Zig. I'm on Zig 013, not on the tip of masters, so I probably won't get it for a little bit. Okay. Let's go into our little test.c. And I guess we probably want this to be like source, like pre-process data Zig. I thought it was Rust XD. I think probably I was talking about Rust at some point. That might have thrown you. That's my bad. Okay, let's go into pre-process data and we'll say const c is equal to c import. And in here, we have to do like a c include of expat.h. And let's just kind of start like adapting this demo code that we had from before into Zig land. Okay, so we're gonna have to have some sort of function start element. I don't think we actually care about end elements in our really shitty version of this, so we'll see though. This takes in any opaque. This takes in a name, which was a const c xml car, xml underscore car, and adders is a double pointer to a const c xml car, and he returns nothing. We'll come back to the contents of this thing. We don't really need an end element. We need to set this to callconf c. I think it's like this. Callconf c. No? Callconf Zig. Looks like Doom on the right. Yeah. It's got the Doom vibes for sure. Callconf all lowercase. .c. Ah, I was close. Okay. We now are in pub function main, and we're gonna have to create our parser. So const parser comes from c xml with lowercase null. Let's just start by commenting out everything and seeing if we can build. Can write export instead of callconf, but I don't want to export it. Since it's a callback, I think that by writing callconf c, this won't get exported as like a C, like a global unmangled function, you know? Okay, we discard some shit that we don't really care about right now. And let's see if this was, actually add this to the build script. So this we're gonna change to WASM, I guess. And then we're also gonna say const preprocess is equal to an add executable. His name is gonna be preprocess. The root source file is from b path source preprocess data zig. His target is the default target, so target comes from standard target options, which now we're going to write target here, and the optimize comes from our opt level. Boom. We need to install the preprocess thing. And we didn't have to limit the stack size on the WASM module, actually. That's stupid. We shouldn't be doing that. That's silly. Okay, C import failed because we have to link libc, as well as link a system library of expat. Let's see. Come on, baby. Come on, baby. Hell yeah. All right. All right. Oops. Preprocess data. We're gonna generate. Are we gonna generate a Zig data file from the XML? I was just going to generate JSON. Generating Zig is pretty funny. Let me think about this. Because then you can just embed it straight into the module, and then everything comes in at once. I was going to process the data from the WASM module. But I do like that better. I think that's funnier. Let's do that. Let's do that. Okay, so after all is said and done, we need to free the parser. So defer this. What is this int done for? So in their loop, they do this while it's not done. Done, it just comes from here. I see. I think we'll probably structure this a little bit differently, but that's okay. We'll get there. Instead of, I guess this file is so big that we can't just read it all at once. It is very large, right? It is 402 megabytes. I guess we could do it all at once. That's a little wasteful. I think doing it streaming still makes sense here. So we'll continue with that way of doing things. Const std is equal to import std and map that sucker. Yeah, let's look at a Zig standard lib. If they have the ability to just mmap it, that is a little nicer. I'd prefer that, so I don't have to think about it. It's. I don't think it's like trivial for me to just be like mmap this file. Yeah, I mean, I think that I should get familiar enough to do that, but I'm not going to right now. You know? I'm not going to right this second. But in the future. I like the idea. We need to make a general purpose allocator. So std heap. It looks identical to the C API. Yeah, I'm just realizing now that I don't know the C API well enough. And we are somewhat time limited. I don't want to go too far past like 4:30 today, so we'll get there in the future. Another day. For now, const GPA alloc is GPA allocator, and now we can get our arguments. Defer std process args free with the alloc and args chillin'. And so now we can look at loading args1. So we say stdfs create, in the current working directory, we create a file. No, we open a file. We expect it to be there. And it comes from this. Okay. mmap file. Feels so weird to me to see this style of docs with Zig. This page just screams Rust to me, which is kind of funny. So they open the file, they search the end, oh, and then they just pass null here. I see. This is the piece that I was missing when I look at the docs. I'm not gonna do it. I'm not doing it, guys. Even though I think you're right. We're gonna get a buffered reader, given f reader. This is gonna try. Peer pressure. I mean, I don't want to like take the extra. I don't think it's like really that much faster or easier is really the thing. You know? I think it might be a little faster, but not that much. We can bully him into doing it. Yeah, you guys, fuck. Does this thing need to be DNA'd at all? This thing returns no failure. Okay, so the buffered reader is like this. We can kind of get rid of all this stuff. I guess we do have to check if the parser was valid. It is a reasonable check. So here we say if parser is equal to null, we return error, no parser. And for now, we don't have to set our I guess we do want to set our element handlers, even though there's nothing in there. We don't have to set our user data yet. And then we can just say, while true, I guess this is like this. We want this kind of down here, I guess. And we forgot to close our parentheses on the end of while true. And then we just start kind of looking at what we need here. So, oh, this is interesting. This is interesting. So they actually extract the buffer from the XML parser? That's surprising to me. That's surprising. I wonder how this is going to play with us. What is buff size? Does this come? Is this like an expat thing? I don't know. That's a very strange constant. Whatever happened with mmap? Okay, guys, we get it. You like mmap. If buff is equal to null, we return error no buffer. Otherwise, we can just read into this buffer. So we can do like buff slice. Probably will make this work okay. So we say buff from 0 to buff size. It's fucking weird. Fucking weird. I almost just want to hard code this. Like, what is that? But I fuck that. Fine. We're just gonna do this. This makes way more sense to me. This thing is probably a U8. What the a void star? Void star. So here we need to like convert it to a U8 slice probably. So it's like buff U8 is a pointer cast of buff like this. And then here we can do this to buff size like this. And then we should be able to like read into it with like our buffered reader read into buff slice. And what is, does this like fail out on empty, or does it will just return 0 at length, I think. Yeah, so we'll say const data red data len is this. If red data len is equal to 0, we break. Okay, this needs to come from buff u8 probably. Cool. And then this stuff, we don't need to worry about this stuff. That's all kind of handled by the Zig library. Then we call parse buffer. This part's interesting. So XML parse buffer. We use the parser. We use the red data len. Looks like we have to incast that probably. And he passes in done? Is done a pointer in this test C? No. So why the fuck? Oh, this is like us telling it if we expect this to be the end of the file. I see. I'm just gonna write 0 here and then just see what happens. If parse ret is, you'll see XML status error. Return error, parse error. But I think it's probably fine. I made a tool that creates Zig schema code from JSON data. It might be useful. I forgot you're using XML, never mind. Interesting. This thing is useful. Test it with pretty large JSON files and GitHub API. Neat. Oh, I see, because you're generating Zig out of it. I see. That's kind of fun. That's kind of fun. Okay, let's just compile this. It doesn't compile. It never compiles. Because I forgot an equal sign here. He doesn't like that I didn't write try somewhere, I bet. Probably here. Probably there. He doesn't like here that start element expected function that shit show found something else. So double star U8, we put double C star U8. Oh, we need to say that all of these things are C stars, or else he doesn't like it. So this gets put like this, and this gets put like this, and then probably he's happy. He's a lot happier. It's a different line that's erroring now. It's expected type some fucking shit show. Cast discards qualifier. Okay. That was a long error message for I need to write var here. Red data len is equals 0 is mad because this needs to write try. But otherwise, it looks like we're chilling. And can we run this thing? So zig out bin part preprocess, and we're running this on planet. Okay, so it's not crashing. Let's try to like maybe do the same thing we were doing before, and every once in a while, print out something interesting. So we'll just do I plus equals 1, and if I percent 1,000, print something. So we'll print out like the user data, and that means that we need to have some user data. We need to have some user data. So we'll do const user data var user data is equal to I guess a user data, which means we kind of need a user data somewhere. And for now, we'll just say num nodes. Again, we'll do the same thing where we try to count the number of nodes. So we'll say if stud mem comp equal name. We kind of need like the len. Is there like a way to get like sentinel? Like I remember there's a way to get like from sentinel terminated to like a string, like just like a normal slice. Span, probably. Take the sentinel terminated pointer and returns a slice. Span name. So we can just say we'll call this name C up here so we can do font's name is this. And then we can do stud mem equal from name to node. And then we can do user data num nodes plus equals 1. And then we have to like figure out this is the context, we'll call it. And then we'll say user data is a user data who is a pointer cast of context. Boom. And then we should be chilling. Oh, I guess we have to build first. Align cast. That would do it, huh? He's also mad that data doesn't exist down here, so this should be called fine. Fine. Missing struct num nodes. We have to set it to 0 up front. And here we do need to align cast. Is it pointer cast? It's align cast first, then pointer cast, I think. I% 1000 is not a Boolean. That is true. That is true. And expected 3 arguments because equal needs a U8 there. Okay. So zig out bin preprocess. He's mad because we didn't pass in our planet argument. Okay, chill in. Okay, so we are now back at the point where we were before, where we can now parse stuff from our zig file. And now I do like the idea of generating a new zig file. I do think that's funny. So how do we do that? Let's just double check zig build system. I want to make sure that I'm following what they do here. So do they they just write to standard output. I think that you can either have an output argument or you can write to standard outputs. Writing to standard output seems fine to me. Seems fine. So what are we gonna do? For now, we are just going to for now we're just gonna throw nodes in. Yeah, so we're just gonna say for each node, fucking dump it. Dump that shit. Dump that shit. So let's do this. Writer is a something. Stood IO get stood out writer. Okay. What the fuck is this thing? Generic writer. Which comes from stood IO generic writer. Oh, with like some like parameters. Ugh. Look, is there like an any? Any writer. Yeah, much better. Then I don't have to think. So then we can say that our user data has like a any writer is or stood out, I guess we call it. It's going to be a stood IO any writer. And then we can do this. We can say user data has our stood out is our stood out writer any. Boom. Is there a buffered writer? I guess I kind of just assumed this was buffered, but maybe we do need to like wrap this with stood IO buffered writer any or something. Maybe. Maybe. He doesn't like that because no field name any in buffered writer, blah, 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 blah. Really? Really? Oh well. Okay, so we can do this the other way though. We can say that we will do this to any. Then here, this is going to be a stood IO buffered writer 496 like this. And then I think everything still is chill. Yep, except now he tries to print that every time, which is fucking annoying. So we'll just print out like user data num nodes. Okay. And then now we can just kind of say that for each of these guys, we're going to write something. So before we even start, I guess we're going to defer stood out writer end flush catch unreachable. I don't know. Doesn't fucking matter right now. And we're going to start by writing out some shit. Is it just write or is it write all? It looks like it's just write. Oh. I see. I'm supposed to get the right. Can I do like stood out writer any? There we go. So we'll call this stood out buff writer, and then we have the writer stood out writer here, and then down here we pass in. Now this can be an any writer without us thinking about it. There we go. That makes way more sense. That makes way more sense. Okay. Okay. So what are we doing? We're gonna write like stood out writer, write all, and we're gonna have like const point is a struct, right? And the struct has like a long and a let, right? And then we are going to make a const points is a point list. Maybe we do this, right? And then here we can just, before we get to the end, we kind of do this. Maybe. I don't know. Something like this. Something like that. Then what? Then what? Then I take a washroom break. I'll be back in like 3 minutes. Be right back. Chat, we're back. Wow, you guys are shit talking me while I pee? How unbelievable. How rude. How unbelievably rude. He doesn't even write unit tests? Fuck. Okay. So here we can just kind of start like ripping points out here. So for each of these guys, because we're gonna have to like look at the attributes, which we haven't actually figured out how to do yet. We haven't figured out how to do that at all yet. So can we do something like we just have lat and lon. We're looking for lat and lon. So I assume that like these XML attributes, what the fuck are these things? What the fuck are they? They're double pointers. And they're just characters. So probably, do you think they're like 2-element arrays? Like where you have like key value essentially? Yeah. Oh, ooh, interesting. Oh, right, because they're double pointers characters. So you just have to iterate by pairs. I see. Okay. How do I know the last element? It must be that the last one is marked somehow. At I. Oh, interesting. So they're using like the index as the condition, which means that the last element is going to be 0. So this is always going to be at least one long. Okay, yeah. So we can do like while while true, var I is equals 0 is a usize. Defer I plus equals 2. And we're basically saying we're trying to set like lat and long here. We're trying to get those values out. So lat, this is going to be an optional. And long. So now we're looking for if the attrs, so we're going to get the span. So const ID, or field name, is mem span of the attrs at I. Simple. Simple. Unless the thing is 0. So if attrs I is equal to null, we break. That is the end condition. Otherwise, we add 2 and later and continue. We say, hey, this is the field name. And the field val is the thing plus 1. So we can do like if field name is the same as lat, we set the lat to field val. Else if we do the same little shit, but we look for lon. We say long equals, I guess we'll say long because I don't like the idea that long could be confused with the type name long, even though it wouldn't in this. Yeah, okay. So now we have the latitude and longitude. And we're gonna do like a std format parse, parse float into an F32 of lat. We're gonna call these lat opt and lon opt. Here. So then I can say const lat is equal to lat opt or else return. Lon is the same thing. Now we can parse these things and then catch return for now. And we can say, we'll call this like lat s and lon s because they're strings. Now we have the latitude and longitude. And we should be able to say user data stood out, write all. And what are we writing? What are we writing? We are writing that we're a element whose x is lat and the y is lon. Oh, we called them lat and long, so. And I'm gonna change this to long here as well. Yeah. Here we are making a blatant mistake, which is that these need to be maybe something like this. But that might work. Close. Close. This is not used, and this doesn't have to be escaped anymore. And we are no longer using names. Oh, we should be using name, though. We should be doing like if name is not equal to node, return here as well. We don't care. Close. Something at 71, he wanted a var here. Okay, we have a double try somewhere like a fucking dumbass, so we got rid of that. Mem equal requires a U8 parameter. He doesn't know the type of the things that he's comparing. I wonder if span needs that as well. Would make sense. Nope. He figures it out by himself. Nice guy. Missing opening brace. Does this need to be like, oh, I need to escape this probably? Probably? That's promising. That is promising. Okay, let's start by just getting like, you know, a couple hundred. Maybe we'll just get the first 1,000. Okay. There's a 0 just sitting here, which is kind of fucking weird. I don't really understand why that's the case. Oh, maybe I'm just fucking printing to standard error and standard error at the same time, like a fucking dumbass, so. Let's double check that. But it's not, why am I not running this? Like, this should be happening. And it's not. So I'm doing something wrong. Unless maybe the flush? I'm not flushing? I'm not flushing. So that would do it, probably. I thought that I had written the flush earlier, but maybe I like lost it along the way. That is better. He does need a new line. He does need a new line. Will make me feel a little bit better about it. Okay. So that's probably valid code. So we can call this like a source for now, points zig. And let's just see if the index, we can say const points is equal to import points zig. Let's just see how fucked up this is. Not fucked up at all. Big win for us. But I guess maybe it doesn't really know that these things exist. So here, we need to basically upload these things as a bunch of float 32 points. So I wonder if it makes sense actually to like kind of just mark them as a like a list of F32s. You know? That's probably faster. So maybe instead of all of this, we just kind of do this. We export some F32s, and instead of doing lat long here, we just do like this. Is that it? So zig build and then do this. Points.zig now. Oh, fuck. It's a really long line. It's a really long line. Is my computer fucked? Yeah, fuck this. Oh, God. Get me out of here. Get me out of there. Kill. 2575867. Sig term. Okay, he got there. He got there. Report. So here we want to make sure that when we generate this thing, we are generating with new lines. Those new lines are very important. So this doesn't actually have to be multiply and string anymore. To be honest, this can kind of just look this. Let's try it again. And we can look at points zig. That looks like valid zig code to me. And let's try just doing something silly. So here, instead of just uploading positions, we can actually probably just do like points pointer and points len. That's probably fine. And then we are going to want it in here, like kind of normalize these things. So, probably what we want to do here is just want to log the maximum somewhere. So we can do like the min lat is going to be like stud math min float max float min. and or this is gonna be the max. Sorry, the min gets the max, and the max gets the min. Right? And we'll do the same thing for lawn. And then here, for each of these, you can say if lawn is greater than user data max lawn, we set it. Or I guess we can even do like user data max lawn is equal to the maximum of lawn and user data max lawn. Then we do this for min lawn and min lawn like this, and then here we say s lawn lat. Okay. Then at the very end of all of this, we kind of go down here, and instead of this being a defer, we do it down here. So we've finished our array of points, and now I guess we can just say every time I do something in the chat, helpful in chat you've already done. Sorry. I can be stupid for longer if you want. Min lat is going to be this. And we're just gonna like shove these in here. Max lat lawn. I guess we want these to be like lawn to match the naming. And then now we can do user data, user, I can't remember if I had an underscore here. I had an underscore somewhere and not somewhere else because I'm a fucking dumbass. Min lat, user data max lat, user data min lawn, user data max lawn. Okay, so now we should be able to like normalize these things in some way, shape, or form. Points is not marked pub, so index. Oh, am I just Oh, there's this kind of interesting, confusing dependency loop going on here because I didn't hook it up to the build system correctly. Okay, for now, because I don't want to deal with this. Hear me out. We just don't compile this. Is this how you do build time configuration? No. Is this how I do build time configuration? Yes. Something is mad again about like missing brace escape. Okay. And if we look at points zig, now we do have. Whoa. I see. So the mins have to be minimum of the max. The negative max, probably. Min is probably min in terms of magnitude. Probably. That looks a lot more reasonable. Okay, so now we can just normalize all of these from 0 to 1. So I guess what we do is we re-enable our build by uncommenting it all. And we can go into index zig now and maybe try to do something like uniform x scale. I'm thinking. Yeah. Uniform float x scale and x offs, and we do the same for y here. And then we have to do something like should just be a couple line hookup in the build system, I think. Yeah, I agree. I just don't want to do it yet. So here, let's reduce the point size a little bit. And what we're going to want to do is like somehow scale this stuff. But maybe before we get to scaling, let's just try running this shit and see how fucking broken it is. Right? Because maybe we'll like, I guess we should see nothing. Redeclaration of minlawn. Fuck! It's a hard enough life for us. It's a hard enough life. What is this called again? Pre-process data. So here, this is supposed to be min lawn and max lawn here. And I'm just gonna go in and fucking heal it manually because I'm a lazy piece of shit. Points, pointer. So these need to be, all of these need to be pub, but again, we'll get there later. No field name pointer. That's true. That is true. So this should be points.points ampersand. Cool. Okay, so if we run this thing now, nothing crashes, but we see nothing, which is reasonable, right? So we can do something like just for now, before we get crazy, let's say uniform x offs equals, and we can maybe we can hard code this into the fragment shader for now, to be honest. We can just look at this and we say, GL position equals, and I think it's, can we edit these on the fly or do we have to copy them out? I can't remember, so I'm just gonna do it. I guess we can just do GL position dot x minus equals 49.10902. GL position dot y plus equals 123.50649. And then the range of this thing, so the y range is going to be like times equals 5-ish. And the y range is just over 1 already. Maybe it's just under 1. 122.8 to 123.5. So I think we can leave y position as is. Let's just go see what happens if we do that. Cannot convert from int to high precision float. So here I probably have to write .o here. And we see only a few things over here. So what the fuck did we do wrong here? What did we do wrong? It's because we're only drawing like a few of them at a time. So this, we need to say points len. Which, no, nothing? Nothing. Why not? Why not? What if I like make 10 of these? Oopsies. So that seems to be working okay. There was a Webgl error in the console. I see only a favicon error, which I think is fine. I'm also not sure I built here. Oh. Attributes only supply. Vertex fetch requires draw arrays instance. Vertex fetch requires this, but attributes only supply this. Over 2. Oopsies. Oh, hell yeah, dude. You're telling me that isn't fucking Vancouver? You're telling me that's not a fucking city? I don't know why it's scaled like this. Because it's -1 to 1, not 0 to 1. That's why. So this should be times 10, and then we subtract 1. Yes. And this should be times 2, and then minus 1. Oh, baby, let's fucking go. Okay, so let's try to, okay, this, vertically we need to stretch this, right? So, vertically we need this to go over more space, so we make them bigger. Maybe 3. Okay, let me try to figure out where the fuck this is. Is it twisted? I think I have my latitude and longitude switched, to be honest. I do believe I have my latitude and longitude switched. I can't really tell. What am I looking at here? Because this looks like it's going to downtown to me. I can't look at the fucking map because I'm going to leak my fucking address. So, one sec. Let me see if I can do this without it showing where I live. Yeah, okay. I think that's not showing my address. So we're kind of trying to figure out how this maps to this. And I think that this down here is this area like this. So I think west is south on this map, right? This sea island looks a lot like this. This looks a lot like UBC here, and this looks like Stanley Park here. So I've got some sort of like fucked up latitude and longitude. Open private tab. No, but the problem is that it just like automatically tries to send my location, which is fucking annoying. Okay, but so yeah, this is Richmond. So this should be, we've got to flip over like y equals x. This has to be like up here. So why is that? Did I get lat and lon backwards? Fuck, I gotta be careful. No, latitude is, oh fuck, latitude is the horizontal lines, which is my vertical offset. Okay, so that makes sense. That makes sense. So let's just regenerate these things. I just want to regenerate it so that latitude just comes first here. So here we do, or sorry, longitude comes first. Okay, so now we build it once, then we build it again. But now we have to fix all those things that we've fucking had broken before. So those were that we would have to write pub on everything. You could technically open dev tools, more dot sensors, and override your location, but then it's kind of annoying. Oh, that's a good idea. I see. I mean, I could also just like stream through a VPN or something. But it's fine. Doesn't fucking matter. I'll just be careful. I'll just be a little careful. Now we have to switch kind of the behavior of our shader code. This thing has to basically say everything we were doing on X before goes to Y, and everything we're doing on Y goes to X. Okay, that's better. It's definitely like got to be stretched out on X more. So, can we do like, oops, wrong way. And then maybe like this. A little more stretchy-wetchy. Yeah, that's pretty fucking good. That looks a lot like Vancouver. Okay, that's sick. So I guess we can just run this with more points and stuff. But I think that is good enough for today. So I think we made like pretty good progress. We have, we took our OpenStreetMaps data, which was an XML, big ass XML file. We processed it into like Zig code. We used that Zig code to embed the data in a WebAssembly module that renders to an OpenGL canvas. The OpenGL canvas rendering is like linked through like some like JavaScript bindings that we wrote. So I think that's actually quite a lot. And I think that's like a pretty reasonable chunk of Vancouver. Pretty reasonable. So happy with that progress today. So I'm going to call it there. It's 4:25. We went a little bit longer, but I think that's okay because I did want to get to this state by the end of the stream. So happy with that. So thanks for watching, guys. If you're new here, there's a YouTube link and a GitHub link in the Twitch description. The YouTube link will eventually, or sorry, the GitHub will eventually have this set up, but it's not there right now. But YouTube has like kind of our previous projects organized into playlists. If you want to check that out, you might want to like check out operating system, neural network, the Robe Goldberg machine may not look that interesting, but there's a lot of cool stuff in there. QR code decoder is pretty fun. Terminal emulator took a while. So that stuff is all there if you want to check it out. There's a Discord link in the Twitch description if you want to get like notifications about like when I go live and stuff, or chat about shit offline. Spheriphoria.dev is now live, so if you guys want to contribute to the like collaborative Rube Goldberg machine, this is going to end up on the side of my screen eventually. I just haven't hooked that up yet, but it is going to hook up. So if you guys want to try contributing a WebAssembly module here, there are instructions on how to do that, and I'll be happy to have your contributions. What else? Like, subscribe, Twitch Prime, all that shit. Let's say goodbye to YouTube and Twitch. Let's find someone to raid.